As we continue to multiply polynomials, we're going to look at the product of two binomials, meaning two groupings with two terms in each. To multiply two binomials, a plus b, and c plus d, multiply the first term ac plus the outer term ad plus the inner term bc and the last term bd. If you're not following what that means, let me show you what I mean. Let's say we have two binomials, 2x minus 3 multiplied to x plus 6. First, we're going to multiply the first two together. This will be 2x times x, which will be 2x squared. This is my first multiplication. Then take the 2x and multiply it to the 6 in the second term. This is plus 12x. This is the outer multiplication. Next, take negative 3 and multiply it to 6. This is the inner multiplication. And lastly, take the negative 3 and multiply it to the last term in the second binomial. That will be a negative 3 times a positive 6, which is a negative 18. This will give me FOIL. That's what it's known for. And then we can combine the middle two terms. So my final answer will be 2x squared plus 9x minus 18. So now let's try this again. If we have x plus 8 times x minus 8, we would have x squared minus 8x plus 8x times a negative, or plus a negative 64. 8 times 8 is 64. One's positive, one's negative. Notice the middle two terms add to 0, and our final answer is x squared minus 64. Let's look at 5x minus 4y times 5x plus 4y. This will give me 25x squared plus 20 xy minus 20 xy minus 16y squared. If I combine the middle two terms, they add to 0, and I get 25x squared minus 16y squared. We call this a difference of squares, just like c is a difference of squares. Let's move on. If we have 3r plus 4 times 2r plus 1, we can FOIL this one as well. 3r times 2r is 6r squared. 3r times 1 is 3r. 4 times 2r is 8r. And 4 times 1 is 4. Combining the middle two terms, we get 6r squared plus 11r plus 4. Let's try D. We have 7x plus 3 times 7x minus 3. This 7x times 7x is 49x squared. 7x times negative 3 is negative 21x. Positive 3 times 7x is positive 21x. And a 3 times a negative 3 is a negative 9. Combining the middle two terms, they add to 0, and we get 49x squared minus 9. Another difference of squares. Let's take a look at this last one. We have x plus 8 times x plus 8. Multiplying the x's together, we get x squared. Multiplying x times 8, we get 8x. Multiplying 8 times x, we get another 8x. And multiplying 8 times 8, we get 64. Combining the middle two terms, we get x squared plus 16x plus 64. There are some special products, and hopefully you're noticing these as we go along. A special product is when you start seeing a pattern, like the middle two terms dropping out when they add to 0. This is what happens when you have two identical terms except for the sign of one is opposite the other. This will always give you the two middle terms dropping out. We call this a difference of two squares. So if we have c plus 5 times c minus 5, let's just practice taking a step where we skip the part where we know the two middle terms drop out, and we can just go straight to c squared minus 25. We square the c and we square the 5, and we know it's a difference because the signs are opposite inside the binomials. The same idea holds for 4x plus 5y times 4x minus 5y. We will get 16x squared minus 25y squared. And lastly, we have this x cubed plus y squared z times x cubed minus y squared z. Well, remember, we're just squaring the first term and subtracting the square of the second term. The pattern will still hold. So if we squared x to the third, that would be like x to the third times x to the third. Well, we know that when we multiply bases, we add exponents. So this is going to be x to the sixth minus y squared squared is going to be y to the fourth. Z is currently to the first, so that will be z to the second. When we square a binomial, that is a binomial that has either both positive signs in the middle or both negative signs in the middle. And you notice that, hopefully, that when you have a plus sign in between, then you get a plus 2ab plus b squared. And when you have a minus sign in between, then you get a minus 2ab. So both terms in the middle are negative. Let's give this a try. If we follow the pattern, x plus 5 squared means that we'll take the first term and square it, so that will give me an x squared. We'll double the two terms, and since it's positive, we know it's going to be a plus 2 times 5x, so that will be 10x. That's what I did. 2 times 5 times x. And then lastly, I know that my last term will be 5 squared. So I could rewrite this as x squared plus 10x plus 25. All right, the next one is 2x minus 5. Now this is a difference instead of a sum. So it's going to be the second example. We're first going to square the first term, so it'll be 2x squared. So 2 squared is 4, x squared is x squared. And then our last term, if we look at the b squared portion, that would be 5 squared. So 5, 25. And then we take a negative. So 2 times 2x times 5 will give you 20x. And it will be negative because that's the pattern that we have been following. And then here is another one, 7x minus 4y, quantity squared. This means that if we follow the pattern, we'll have a minus plus. We'll square the first term, that'll be a 49x squared. We'll square the last term, that will be a 16y squared. And we'll take the product of the two terms and multiply it by 2. So 7 times 4 is 28 times 2, and it'll be an xy, because x is in the first term and y is in the second term. And then if we multiply it by 2, we'll have 56. So minus 56xy. Square the first term, that will give me a 4a to the 6th. Square the last term, that will give me a 9b to the 4th. And then we need to take the product of the two terms. So that will be 2a cubed times 3b squared. That will give me a 6a cubed b squared, and then we'll multiply that by 2. This will give me a 12 a to the third, b to the second, and I'm just going to drop my signs in there according to the rule. It was a negative in between the two terms, so we're going to use this second rule where I'll have a negative and then a positive.